Hello friends, in the previous video we have seen problem on shear force diagram and bending moment diagram. Here again we have one more problem on SFD and BMD. See the problem. Draw shear force diagram and bending moment diagram for the beam shown in figure. See, this is the problem from December 2015, Mumbai University. You can see the beam is given, horizontal beam is given. See, from A point to B, distance is 3 meter, B to C, the distance is 2 meter, C to D, you can see the distance is 5 meter, D to E, distance is given 2 meter, total distance is 3 plus 2 plus 5 plus 2, that is 2 meter. At point A, hinge support is given. You can see this is at point A, hinge support is given. First of all, you have to identify types of support. At point A, that is hinge support is given. You can see at point D, the roller support is given. The contact surface is horizontal. You can see here at point D, roller support is given. Now see types of load. At point B, the point load is given, but it is inclined horizontal to the beam. See, the angle is 60 degree. You can see for horizontal line to this force, the angle is 60 degree. 15 kilonewton is a point load which is acting at point B. 10 kilonewton is acting vertically downward at point C. And from C to D, you can see uniformly distributed load is given. The intensity is 3 kilonewton per meter. So you can see at point C to D. Then at point E, vertically downward force is given, that is 6 kilonewton. See, we know that the first step is to calculate free body diagram, and you can see the support reaction. To calculate support reaction, there will be two reactions. First one, that is vertical, and the one more, that is horizontal. So RAX will act in the horizontal direction and RAY will act in the vertical direction. Here at point D, there will be only one reaction, that will be vertical. RD will act in the vertical direction because contact surface of roller is horizontal. So there will be only one reaction, that will be vertical, that is RD. Now you have to calculate support reaction. To calculate support reaction, you have to use condition of equilibrium. First condition of equilibrium, that is summation of a moment at point A is equal to 0. Clockwise positive. The assumption that is very important. Here we are taking clockwise positive. So you have to start from left. RA is passing through the same point, so there is no perpendicular distance. RA passing through the same point, so the moment will movement is 0. RAX, that is horizontal, that is also passing through the same point, the movement will be 0. So now next, unknown, there is only one unknown, that is RD. So RD will move in the anti-clockwise direction. About A, that RD will move in this direction, that is anti-clockwise. So minus RD into perpendicular distance from A, that is 10 meter. You can see 3 plus 2 plus 5, that is 10. So RD into 10 plus, see, this 50 kilonewton is acting on point B, that 15 kilonewton is inclined, so there will be two component. First one is the horizontal, that is 15 cos 60, and the one will be vertical, that is 15 sin 60. 15 cos 60 is passing through the same point A. There is no perpendicular distance, so the 15 cos 60 into 0, the component will be 0. Now the next 15 cos 60 is acting vertically down, sin 60. 15 sin 60 is acting vertically downward, and it will move in the clockwise direction. So 15 sin 60 degree into the perpendicular distance is 3 meters, so into 3. Now next 10 kilonewton is acting vertically downward, so 10 kilonewton will move in the clockwise direction from A to that 10 kilonewton. The perpendicular distance between A to 10 kilonewton, that is 5. So plus 10 into 5, you can say 10 into 5. Now the next, you can see 3 kilonewton per meter, that is UDL from point C to D. So intensity of that force, that is 3 into 5. You can see here 3 into 5, and it will act at the center of this distance. So 5 by 2, that is 2.5. So here that force will act vertically downward. So about A, it will move in the clockwise direction. So plus 3 into 5, that is the intensity of equivalent point load, into perpendicular distance from point A, that is 7.5, plus the 6 kilonewton is moving clockwise. So 6 into perpendicular distance from A, that is 12, is equal to 0. So RD is equal to 27.35 kilonewton. There is only one unknown, that is RD. You will get answer RD is equal to 27.3 kilonewton. Now, by using another condition, we know that all the upward forces are positive, downward force is negative. So summation of Fy is equal to 0. That is another condition of equilibrium. So now we have the value of RD. Just we have to calculate the value of Ra. Upward positive, downward negative. So Ra, that is positive, is equal to 15 sin 60 degree plus 10 plus 3 into 5 plus 6 minus 27.35. You will get the value of Ra, that is 16.65. You can see in the diagram. Ra, we have the value of Ra, that is 16.65. Here we have the value of Rb, that is 27.35. We have the vertical component of 15 kilonewton, that is 15 sin 60 degree, that is 13 kilonewton. Here at point C, we have 10 kilonewton. Here at point D, we have reaction. Here from point C to D, we have UDL. Now the next, at point E, we have 6 kilonewton. See here, 6 kilonewton is acting vertically downward. See, after calculating support reaction at point A and at point D, the very important concept is there to calculate shear force calculations. See, the diagram shows point A, B, C, D, and E. See, this part is very simple and very easy. From left to right, you have to note down each and every point. Shear force at point A just to the left, at point A just to the right. See the cursor location. At point B just to the left, at point B just to the right, at point C just to the left, at point C just to the right. Again here at point D just to the left, just to the right, at point E just to the left and just to the right. See, you have to write shear force at point A just to the left, shear force at point just to the right, shear force at point B, at point C, at point D, at point E, just to the left, just to the right, just to the left, just to the right, just to the left, just to the right, just to the left, just to the right. See, this is very important and marks giving step, that is shear force calculation. See, you know that positive shear force and negative shear force and its convention. You can see this is the left side of a section, this one is the right side of the section. This is the positive shear force. According to, you have to put the positive and negative signs here. See the cursor location, you have to come at point A just to the left. You have to consider left side forces. There is no any left side force from point A. You can see the cursor location. Left to this section, there is no any force, so 0 kilonewton. Now come here, shear force at point A just to the right. RA is moving towards upward direction. You can see the upward direction of RA. So plus 16.65 kilonewton. Similarly, come at point B just to the left. You can see only RA is moving upward in left side. So shear force at point B just to the left is positive 16.65. See, come at point B just to the right, see the section, consider all the left side forces, plus 16.65 minus 13. The answer will be 3.65 kilonewton. You can see here. While calculating C, come here and consider all the left side forces. RA moving upward, 13 kilonewton is moving downward. So plus 16.65 minus 13. Answer is 3.65 kilonewton. Now come at C just to the right. You can see just to the right. Consider all left side forces from the section. Every time you have to consider all the left side forces from the section. So at point C just to the right, you can see RA upward, 13 kilonewton downward and 10 kilonewton downward. So plus RA minus 13 minus 10. The answer will be minus 6.35 kilonewton. Now see D point, D just to the left. See the location of cursor. Again, you have to consider all left side forces. Plus 16.65 minus 13 minus 10 minus 3 into 5. That is minus 21.35 kilonewton. At point D just to the right. Next step, you have to consider all left side forces. RA positive minus 13 minus 10 minus 3 into 5 plus 27.35. The answer will be 6 kilonewton. Now come at point E just to the left here. Consider all left side forces. Plus RA minus 13 minus 10 minus 3 into 5 plus 27.35. The answer will be 6 kilonewton. E just to the right. You can see this is the last point, E just to the right. Shear force calculation. You have to consider all left side forces from the section. So plus RA minus 13 minus 10 minus 3 into 5 plus 27.35 minus 6 is equal to 0. You can see shear force at point E just to the right is equal to 6 minus 6, that is 0. So again you can see here shear force at point A just to the left is equal to 0 and shear force at point E just to the right is equal to 0. Maximum time, the answer at end point will be 0. You can see. You can cross check the values also. Now the third step, bending moment calculation. As we know that as a end point, bending moment at point A is equal to 0, bending moment at point E is equal to 0. Now just you have to calculate bending moment at point B, bending moment at point C and bending moment at point D. See, while calculating bending moment, the sagging and hogging concept is very important, means positive bending moment and negative bending moment concept is very important. Whenever you will consider point B, there will be only one force from the section at the left side, that is RA. RA will be move in the clockwise direction about B, so plus 16.65 into perpendicular distance 3. So answer will be 50 kilonewton into meter. Now the next, bending moment at point C. Here you can see here. You have to consider all the left side forces from point C. So RA, that is 16.65, is moving in sagging condition. So 16.65 into perpendicular distance from C, that is 5. So 16.65 into 5 minus, because this 13 kilonewton will move in the hogging condition. So minus 13 into the distance between B to C, that is 2 meter. So minus 13 into 2. Answer is 57.2 kilonewton into meter. Now the next force, bending moment at point D. Next, bending moment at point D. So bending moment about D is equal to, you can consider either left or right. Here left side we have n number of forces. To get the answer in minimum time, you can consider right side also. So towards right, you can see 6 kilonewton and it is moving in the clockwise direction. So according to the sagging hogging concept, it's a hogging. So minus 6 into 2 is equal to minus 12 kilonewton into meter. So hogging because right side of the section 6 kilonewton is clockwise. So while calculating bending moment at point D, the sign is minus. So minus 12 kilonewton into meter. And bending moment at point E is equal to 0 because it's an end point. Now you can see this diagram. This is the given diagram. Here we have the values of shear force calculation. For RA, the values is 0, 16.65. At point B, the value is 16.65 and 3.65. At point C, the values are 3.65 and 6.35 minus. Then at point D, it's a minus 27.35 plus 6 kilonewton. At point E, the values are 6 and 0. See, from A to B, there is no load between A to B, so line is straight. B to C, there is no any load, so line is straight. But from C to D, UDL is given, so you can see here inclined line in the shear force diagram. From D to E, there is no any load, so line is straight. So this is your shear force diagram. Here, positive sign, this one is negative sign, and again there is a positive sign. Similarly, you have to draw the bending moment diagram. You can see the bending moment diagram. This is A point. At point B, we have 50 kilonewton into meter. At point C, the value is 15.25 kilonewton into meter. At point D, that is minus 12 kilonewton into meter, and at point E is 0. But you can observe from 0 to A, from A to B, there is a straight line. So here, inclined line, you can see in the bending moment, there is an inclined line. From B to C in shear force, for B to C, the straight line. So here there will be inclined line. But from C to D, you can see in the shear force, there is an inclined line. But in the bending moment, if UDL is there, then there will be a parabolic curve. You can see this parabolic curve. And from D to E, there is a straight line. So here is, in the bending moment, there is an inclined line. This is the shear force and bending moment diagram for given problem. One more important point, that is point of contraflexure. Point of contraflexure point is very important. Means this one is your intersecting point of the bending moment. This point intersects the baseline where the bending moment at point XX is equal to 0. You can consider this one is as a XX is equal to 0. Bending moment at XX is equal to 0. And according to that, you have to calculate the values. Now, see the formula. Here I am explaining that formula. Point of contraflexure is very important. So I am explaining here how it will come. Please concentrate on this point. Here I am explaining. See, consider this point as a XX section. Now, just take a faint line and draw XX section here. From that XX section, consider right side, means total distance from point E, that is X. So here, this 6 kilonewton is moving in hogging condition. So minus 6 into, already I told you, suppose that X point is here. Then from this X point to E distance is X. So minus 6 into X plus another force, that is 27.35. It will move in the sagging condition, but the distance will be X minus 2. So 27.35 into X minus 2 plus next minus, see X distance is here, and from that X distance to D point is from that X point to D point. There is a UDL. So 3 into the distance is X minus 2. So 3 into X minus 2, and it will act at a distance of X minus 2 by 2. So minus 3 into X minus 2 into X minus 2 divided by 2. So the term will be 3X minus 2 whole bracket square upon 2 is equal to 0. There is only one unknown, that is X. You can calculate the value of X. Only the important thing is that either you can consider left side of X point or you can consider right side. Here we have taken right side. If you want to calculate at left, you can calculate at left also. But try to select the point, or you can see the side where minimum forces are there. So it will be more easy to solve the problem. So the first step is to calculate support reaction, that you know how to calculate support reaction, then shear force for every point just to the left and just to the right. After that, bending moment. For bending moment, the concept is sagging and hogging. That concept is very important, sagging and hogging. And next, point of contraflexure. Here I have completed the important point, that is point of contraflexure also. In the next lecture, we will see another problem.